So, wonderful good afternoon, dear BDLI, ILA stage community, LinkedIn community, Composites Lounge members. I see also Composites United here today, and many more that are even engaged in building up connections to Korea and all these countries. This will be a special session today because we are actually a material supplier, value chain here and producing planes. So we will look at the value chain today. And before we dive into that, let me thank you so much for attending our panel here. We did some extensive announcements already on LinkedIn because we know each other all from LinkedIn. And if you don't know us yet, please connect with each and every one from us with us in LinkedIn. We have a community that is called Composites Lounge. I assume that every one of you knows what a composite is. If not, just in a nutshell, if you add two materials together, both of them in its combined performance have a higher performance than you would use them on their own. And this is why we are so enthusiastic about composite materials, because they are the future in lightweight technologies and in mechanical strengths and any properties you are looking for example, in the airplane, in the traveling. And our aim today here is we want to ignite composites with you. Not only composites, but also the propulsion of planes in order to be CO2 free in future. So this is our mission. Let me walk you through some of the slides that I've prepared. So the Composites Lounge is a LinkedIn community. Unless other communities that have associations, we are only focused on LinkedIn. We are, as you would call them, content creators, in brackets maybe some influencers, in partnership with the JEC Group. This is a media hub worldwide on composites. We are conducting panels like these in order to promote, of course, composites and also enable modern materials, advanced materials to be used. You can follow our sites, as I said here. So we have these end-user panels. Then the aerospace. Today we are here to talk about aerospace and CO2 reduction, and batteries are one way of CO2 reduction, an important way. And this is our core of our topic today. And as I said, we are having here a major part of the complete value chain, and that makes this panel also so interesting, that from the raw material to substrate production to airplane production and even operating these airplanes in the future, everyone is involved here. And I would like to introduce you my guests today. So left of me is Marc Fette. He's the CEO of CTC GmbH, which is an Airbus company up in the north in Germany, in Stade. I know Marc for a long time now. He's also wearing a lot of hats. For example, still president or chairman of Composites United. And then we have Markus Kochs-Kämper. And Markus, he is a leading figure at Vaeridion. Yes. And then we have Swedersky from CustomCells. And last but not least, we have Norbert. I was here with Norbert already last year on this ILA and BDLI stage. Thank you, BDLI, by the way, for providing us with this nice platform here. So, let's start now with getting into, first of all, the propulsion of the airplanes of the future. Now, with Marc, I had a nice warm-up discussion, and Marc always would say, well, in aerospace, we cannot think one-dimensional. We have to think in several dimensions. And Marc, I would like to ask you to give us some form and some overview of the types of propulsion that you see for the future as a first insight into this panel discussion.
First of all, I have to say thank you very much that I could be here and part of this panel discussion. I guess when we speak about propulsion system, energy sources, we cannot make a change with existing architectures. So we are also talking about new aircraft architectures, and with new architectures, new propulsion systems, also the industrial system is really influenced with this, and also the infrastructure we are needing, for example, at airports, depending on the system. In my opinion, I can say the battery electric flight is one option for the future. And today we have maybe some single ways to make a propulsion system when it comes, for example, for commercial aviation. But in future, we will have a complete mixture of this, depending on the aircraft system, on the aircraft architecture, on the purpose, on the capacity, on the size, on the range level, and also on the operational use on the missions we are flying. So from battery electric flight systems to systems which are maybe hybrid electric. Of course, also sustainable aviation fuel plays a really important role when it comes to the synthetic ones or the biogenic ones, and also hydrogen, liquid hydrogen, and all these options will play an important role, depending on the time, depending on the strategic horizon, and of course, depending on the area system we are looking for.
Thanks for the overview, dear Marc. And let's move to Markus. Markus, now, the interesting part of your company, Vaeridion, is that you're looking into a plane that is developed from a clean sheet. This term I heard the first time, last time in 2022 from Ivor, the managing director, CEO of Vaeridion. Now, let me ask you, why did you start with a clean sheet development? And is actually the battery the cause for this? Because this is something that we didn't discuss the last time. What was the cause of getting into a clean sheet and development?
Well, first of all, thanks for the invite. So we have two angles. The clean sheet gives us the opportunity to have a very aerodynamically efficient aircraft, because this is what we need. We need efficiency, as battery technology, and we are developing a battery aircraft, is not there yet where we want it to be. But we can, and as you said, right, we start with the battery, and we will more or less build the wing around the battery, because with this high integration of the battery into the wing, we will be able to achieve the most efficient and most valuable aircraft. And therefore, we need also to have the hand on the battery development, where we, for example, have already used some material testing for composites, because the housing of the battery, we will do the modules ourselves, will be composite material, and we will integrate that into a composite wing. So this is the best and only opportunity how we can have an aircraft which is flying roughly 400 kilometers with the existing cell technology. And so, yeah, you're right. The battery itself is the driver. We put them in the wing because this gives us the opportunity to have a very light wing design, because the weight is counteracting to the bending moment of the wing. So all in all, the battery itself is the key driver for our aircraft. And yeah, this makes electric flight possible, coming from the bottom-up approach with a 9-seat, 5.7-ton aircraft.
Yeah. May I ask a follow-up question on this one? You said the batteries are below truckwerk,
Well, they're actually in the wing.
In the wings itself.
Replacing the wing, so to say, the fuel, so to say.
So from my little knowledge about flying and aerodynamics is, you have always this center of the weight distribution. So is a battery actually an enabler of this weight distributions, or do you have special challenges with it?
Well, in the way how we set it up, we have a rib-based approach, which means we have a large number of modules which we put onto the rib of the wing, which gives us the bending moment of the wing, but will keep as lightweight as possible.
So lightweighting, of course, an important feature of composite materials. And I'm glad to summarize your part that you use the clean sheet design in order to get these modern materials incorporated in this airplane design.
Exactly.
Yes. Okay. So let's move now to the battery itself. With Eric Swedersky. He's been delegated by CustomCells. He's the senior vice president of CustomCells and in the commercialization part. And with Eric, I would like to discuss the specifics of batteries. Now, again, with my small knowledge about flying, I'm a flying enthusiast. By the way, I have a pilot license on Microsoft X. You know, the Microsoft Flight Simulator. So I'm really a interested party, but let's talk about this battery. And the battery for me is some sort, in German we say Buch mit 7 Siegeln. And I would like to pick Eric's brain to get a little more insights into the batteries, because batteries have actually two aspects. The one aspect is the electromechanical, chemical aspect. And the other one is the software or the electrical aspect of it. And I would like to dive into the battery first on the electromechanical side. Eric, just in a nutshell, please explain us what is the challenge of an the mechanical properties of the battery. Is there some specific things that you need to observe on planes?
So, just in a nutshell.
Yeah, in a nutshell. In one sentence.
Yeah. One sentence.
No, more than that.
Let me say again, like the others, thank you so much for having me here and being part of this great and esteemed panel. So from CustomCells, we're a German battery manufacturer, manufacturing the cells. So the actual cells, that you would imagine looking like a battery, in many different forms. We're quite focused on tailor-made solutions or tailor design solutions, looking to electrify those very hard to electrify aspects of electric mobility. So things like electric aviation are very much our focus point. We've been looking at lithium-ion batteries for our history for 10 to 12 years now, sort of the state of the art of where it is. And we work with great folks like Vaeridion, as well, and sort of some of the very lead mark manufacturers, OEMs, that are in this space right now. So when you're designing these rechargeable batteries, these lithium-ion batteries, it's always a balance. Ideally, what anyone wants is to have the best of everything. Unfortunately, that is completely not possible in this kind of an aspect, this kind of a design element, where you're really looking at factors that potentially could be inversely relational or things that you can't have necessarily all at the same time. This is the case regardless of what kind of lithium-ion or rechargeable battery that you're looking at. So, you know, whether you're talking about an auto EV, same problem or challenge, I would say, not a problem. It's a challenge. But it is twofold, threefold, fourfold more important when we're talking about electric aviation. So I can give you a few examples of that. Something like even power or energy. Let's just take two very simple ones. Power would be kind of the oomph, like how do you get the oomph to move something? And energy would be how long can it do it? And if we're talking about a particular kind of aircraft that takes off vertically and lands vertically, you need a lot of power. At the same time, when we talk about the business models for these kinds of new airplanes, obviously being able to fly a decent amount of time, a decent amount of distance is very important inside those business cases. So you have to balance. It's not always possible to have the absolute most of either one. A lot of these things are measured inside densities. So it's sort of the measure of the power or the energy against something like a kilogram or a liter. And so exactly as our previous two responses were, we're talking about weight there. So what's the material we're going to use? Are we going to use composites? Are we going to use aluminum? Are we going to use steel, for instance, or stainless steel? And these come into play when we start to think about things like thermal management. Very important, very critical. Batteries, when they produce energy, they produce heat. And if we're talking about very high spikes in demand, These batteries can heat up very quickly. They have to be managed in a certain way. And so depending on what material we use, it actually makes a difference on how we can shed that heat and that kind of thing. You mentioned electrochemical. Electrochemical is also very critical when we start to think about A, producing the kinds of things that we want to have, but B, some of the second and third order effects is how long does it take to charge? How many times can it cycle? These kinds of batteries, you know, when they're working in airplanes, you would never take them down to a state of charge, you know, where you would expect your phone to be when a little red light comes on and it's, you know, below 20. These will never get there. So, you know, will they work when they're only ever going down to 80%, you know, state of charge, that kind of thing. And all of that, you know, gives you an indication or a sense of the kinds of challenges that we're solving as we take these sort of next generation batteries or advance the state of the art to meet a use case like Vaeridion's.
Yeah, I'll also have a follow-up question, if you don't mind, Eric, to you. So this is interesting. You say the battery comes never to this red level. Yeah. And what immediately strikes with me is, of course, in the plane, you have to be careful how many pounds, kilograms, liters, whatever your measure is, put on kerosene in the plane. And in this case, I mean, the battery, whether it's full or not, the weight is basically the same. So you don't need to consider that as a factor. And therefore, you can always charge it full and keep it full alive, which is it's a great thing. And I'm moving here maybe towards safety. Is that a safety regulation that it never has to come down to red, or is it just your own approach to battery?
So there are a few aspects there. I mean, I can answer quickly because I don't want to take all the time from Norbert. So one is sort of the way that these airplanes will operate. So if we imagine them, you know, what we're looking at here is regional air mobility with someone like Vaeridion. If we're talking about something that's more urban air mobility, sort of the air taxi, we're talking about very short flights. So these wouldn't be things that would go long enough. And you would always have the ability to then recharge. And so you're not going to see this, you know, sort of long flight. So that's one aspect. The other aspect is, just like the regulations that we have today for conventional fuel, there are always, loiter amounts that you have to have. There are reserves that you have to have. And so these are the kinds of things that I'm talking about as well, that you have to be able to keep in the battery. But also, you know, you have to be able to still have that power. So you still have to be able to maintain, even though there's, you know, some electrochemical sort of magic happening there, and we're decreasing the state of charge. You still have to have that power available if you need to do a missed approach or hover to land or whatever. So all of those things come into play.
Okay, very nice. Thank you so much for enlightening this. And now, Norbert, you will be operating electric planes in the future, but you are already operating planes today. Community, you have to know during the lockdown, and imagine this is really one of the highest points of the lockdown, where we were walking with masks and planes weren't available. Norbert and his crew flew me from Bayreuth, Bindlacher Berg to Stade. No, actually, we couldn't land in Stade because the landing was too short. So we used as an alternative Rothenburg-Wümme. So if you are from Rothenburg-Wümme, this is close to Bremen somewhere. So we did a point-to-point connection, and we had a conference there. Composites Lounge Conference 2.0. We did it, of course, under all the distance stuff, but it was great to have Norbert's team flying us there, because so we could use our promise of getting the people together, not only on LinkedIn and digitally, but also get the organizers and the hybrid streamers together in one place. Now, Norbert, knowing that you are connecting over 200 airports with planes that fly business travelers, individual travelers, even private people around. So if we look at the scenery that is coming up with the batteries, So how will future airports and how will you operate with batteries in future? Give me a glance. I have no clue. So far, when I'm going to a plane, I see there is someone putting the gallons in the plane. And when they're finished, they close the lid and then off we go. How will this be in the batteries? And is German airports already ready for this?
Well, thanks for having me here regarding the individual air mobility that you have already experienced in that time. Yeah, that's what we operate every day for our clients, be it a propeller airplane like you flew, which is very cost efficient, or even private jets with all the comfort level that they provide. But it's really individual air mobility, and the future with electric airplanes gives us even more possibilities there with those, for example, 200 airports all over Germany and over 2,000 in Europe to fly people individually from point to point. And yes, as we have today, even at the small airports, different scales of infrastructure. Sometimes you have a full equipped gas station, like for gassing up the airport, the bigger airplanes. Sometimes you have a trailer with a gas can on it, with a tank on it, and you drive with the trailer to the airplane. So you will have also different scales in the future for such charging stations. But of course, the infrastructure, like at the beginning of the EV trend, is not yet existing at the airports. But it will be in the time that Vaeridion, for example, is developing now. The airplanes will be established as well, because you can do many nice dual uses as well, with charging stations for electric vehicles, charging stations then for airplanes. And the technology is actually already developed. We know there are 350 kilowatt chargers, which would be sufficient already today. And even for a bit bigger airplanes, like 10-seat airplanes, the megawatt chargers that are currently getting online for the trucks will be sufficient. Of course, this will be needed to be established, but it will be a nice business model to install also such chargers at those points. And you see it already right now at the gas stations, how many different companies are trying to get that market divided under themselves.
Okay, that's good news then. In the future, possible to exchange the batteries and load the batteries. Now, from a composite producer standpoint, Marc, you are a very large composites parts producer. I've been to your 20th anniversary, or was it 25th?
20s.
20s, yeah. And I saw this Langzauner press, 1,500 tons. Now, people, you have to imagine they have a press that can press 1,500 tons. And within my world, coming from the textile industry, we are working with presses with 20 tons, 25 tons. And they have a 1,500 tons press. And I said, Marc, who on earth needs 1,500 tons of force for a press? And he said, Ilkay, it's a question of mathematics. Look at the size of the parts. And of course, these parts are like 1.8 meters or even larger than that. And if you now take this force and calculate it down, then the force on each square millimeter is not that high. But let's come to the battery or the hydrogen propulsion. What I'm asking myself is, you as a composite producer for the aerospace industry, is there a difference for you whether you will supply in the future kerosene-fired gas turbines, hydrogen-powered airplanes, or electric planes? What is coming as a challenge to the composite producers?
First of all, we are more working in the field of technology development and to develop holistic lightweight solutions. The aviation and the aerospace industry has been always driven by lightweighting, and lightweighting is especially key when it comes to sustainable aviation, to reduce the resources of the materials we have to use for an aerial system, and at the end also for the operations, to lower the energy we are consuming and also to lower the emissions at the end when we take into account the overall value chain. The second point is, when we talk about new propulsion system, most of these propulsion systems we are talking about will be much more higher in the weight than we have today with existing propulsion systems which are integrated. It's not the same for every option, but for a lot of options. So we have to lower this weight that we have the same efficiency of the area system. This is one point. And there's also an opportunity. I always mentioned, or already mentioned, when we are changing the propulsion system, the energy source, sometimes we need new storage systems. And this allows us also to change the architecture of the aircraft. And there's a lot of potential also to use composites, to use lightweight designs, the appropriate process technologies. And just some simple examples, the housing structures, when it comes to functionalization, composites plays an important role and offer a lot of potential for this. The other option is when we are talking about hydrogen. The storage systems, when it comes to compressed or also to liquid hydrogen, there's also a big potential to use composites exactly for this, to realize it and to be in a weight level for the overall system, which brings some efficiency and which allows flying and connecting people.
Okay, that's good news then, that the composite industry can follow suit and basically whatever the propulsion system, we are in the game. That's the good news. Now, Markus, circularity is one of your key values in the company. Let me share your personal thought, a personal view. Apple has brought this new iPad Pro. Have you heard about that? iPad Pro? That iPad Pro, I need that for video editing, and the configuration comes out to one like 3,000, 4,000 euros, whether you have the magic key or not. Yeah. So it's a heavy investment. The question I'm having as a private consumer is knowing that the battery one day will be collapsing, not working anymore. I've spent 3,000 or 4,000 euros on an iPad and then the battery doesn't work. Brings me to the question, Vaeridion, do you have this in mind? What happens to your plane once the battery will come to its end of its life? And then the question is, what happens with the plane?
Well, basically, we don't want to throw away the aircraft when the battery is down. And we don't deplete the battery to a point that we have to throw it away. Yeah. So circularity is really something we keep in mind because our battery will have at least 2 lives, I would say, maybe even 3. So we have the first life when we install it in the aircraft, and it will be, I mean, replacing the battery, which will be with the existing technology, maybe every 1,000, 1,500 cycles, is a scheduled maintenance task. So it can be done during a, I don't know, A or B check. And then you have the opportunity to get even better batteries, which gives you more performance. So this is the first time in aviation when an aircraft gets older, gets better. But, coming back to the battery itself. So the battery which we replace has about 80% state of health, which is really still a good battery, which you can use in a second life. Why install it at a buffer? You install it in the house. You do some grid, or you can do even charging with them, right? You put it on a truck and do remote charging. So this is the second life we see. And then even the third life is recycling. So we can reuse the materials which we have used for building the battery. We are already connected with companies at the early stage when we are still testing if the cell is working as we want. That we can have them recycled and bring them back into the circularity. So we think holistic in terms of the recycling and the circularity and the approach of the aircraft. And therefore, I mean, we talked before, right? We are building a CTOL. So we want to use existing runways on existing airports. So this, what we see is a sustainable approach.
Okay, so we should send then Tim Cook, the Apple CEO, to you and learn from you guys how batteries can be managed in the future. So let's come then to Eric, the battery itself. Like we said, 2 aspects. One is the electromechanical and the second one is now the battery management system. Now, I'm assuming I'm a pilot. As the pilot flying, I would always like to know where is my battery stand today. So in order to do that, this is the most probably simple function of the battery management system. In order to do that, and in order to provide the pilot flying with all the information about the battery, how important is that? And is that actually one of the key functions that you need to apply for a FAA or ESA approval?
It was an easier question until you mentioned certification. But I'll split it into two very quickly. So CustomCells, as I said, we deal with the actual cell. So the actual battery cell is often then taken by a tier one supplier or by an OEM and built into battery packs. And then part of that integrated system is what you mentioned, the battery management system. And I'll answer as a non-expert here on BMS. CustomCells has sort of spun off that aspect of the business into one called Resolute right now. But I mentioned sort of the complexity of the system and managing all of these factors in the cell itself. This carries forward when it's actually in operation. And so I would kind of break it into two. There are things certainly that the operator pilot would want to see. You know, what's the state of health? What's the state of charge? How much capacity do I have left? Maybe I want to know the temperature. Maybe I'm interested in the voltage. I probably want to see some warning indicators. So it might come into my primary display. There might be some warnings. The battery management system, actually, it's the stuff that maybe even isn't being displayed that's actually really, really critical. And it's things like current balancing and temperature monitoring and doing voltage regulation and deciding, oh, this cell is a little hot. I've got to cool this one down. And maybe this one's way too hot and I've actually got to isolate it. And all of this stuff is happening independent of an actual, person who's making that choice. So it's a fairly complex system. And I would say definitely at least two separations of the kind of information that's there. The certification one or the airworthiness one, it's a bigger question, but it's like any component. So I think these processes are fairly well known, whether the regulator be EASA in Europe or the federal administration in the United States. It's a fairly set process where you have to know what regulation, what method of compliance you're going to do. You have to go through several design steps and testings and validations and then certifications, et cetera, to get there. What's maybe interesting here is to date, typically in these electric aircraft, the actual cells themselves are not going through necessarily that process on their own. So they're actually being ingested into an organization that's called a design organization approval, or and potentially us too could be a producing organization. And they're the ones that are doing the actual certifications. And then as CustomCells, we've been doing verification and validation to feed into that system and be able to make sure that we're staying compliant. We think that we could actually start to take this down a level. We think that we could actually look at doing the individual cells themselves as we start to see them as maybe components that could go in multiple types of aircraft, some kind of dominant design. And so we've started that process where we're going to apply for this design and production organization approval side, which we think could be quite a differentiator for European or American producers as we start to build this actual electric aviation capability in the ecosystem in Europe and North America.
Okay, wonderful. So let me come then to the human factor with Norbert. Norbert, the pilot's flying, yeah. With all these new airplane technologies coming up, propulsion system, whether it's hydrogen or batteries. You all remember Sully Sullenberger, who landed on the Hudson River? Hands up, who knows? Who remembers? Most of you remember, right? So he was faced with a situation that no pilot before, not recorded before, had a situation to deal with it. And fortunately, we would say, he did a great job there and landed it safely, and all 150 or so souls were rescued. Now, Norbert, the pilot has to be qualified. The pilot has to be educated. The pilot is a human factor. Now, with all these new technologies coming up, how will you make sure as an operator that they keep up with all these new challenges that are, or let's call it requirements. They're maybe not challenges, requirements that they are coming up to them. They must now read batteries. They must now know what kind of Werkstoff materials are put into the plane with its capabilities to load factor. How will you keep that up?
Well, the good thing is that actually electric airplane is simpler in the end, because the combustion engine, be it a turbine or be it a normal piston engine, is very complicated actually today. But also the pilot training is already today changing to electric aircraft. So we have already a certified electric aircraft, which is a twin-seater, where more than 100 airplanes are already delivered all over the world. There are, like in Switzerland, already 14 flying in actual flight schools. In Germany, also several. So today's pilots are training already on electrical airplanes more and more. And also outside, you see an orange motor glider that will be now certified and is already able to fly 300 kilometers. So quite longer time on one battery charge, and be then used for real ATPLs or real commercial pilot training. So actually, I think it comes all with time in parallel, because of the small airplanes will be the first to be really electric. And that's what we also will use for our clients to fly then from A to B. But of course, with time, the distances will be longer. And with time, more and more old airplanes will be substituted by modern electrical airplanes.
So the human factor remains strong with the new pilots flying. Do we need a pilot monitoring in future if you say it becomes easier to fly those?
Well, you need to have the skills to read the EMS, so the electric management system. The same like you in the past were reading the piston engine temperature, the cylinder head temperature. Those were skills that you needed in the past. In the future, we will be more electric focused.
So the pilots is a safe job in the future. No AI there.
For sure. Well, some pilots, many of the airplanes are already equipped as a single pilot configuration. So the additional pilot will be maybe backup systems on the ground, like we see in the military. But that's coming up in the future.
Okay, wonderful. So this is our last round of questions. By the way, if you have any question, keep them just for a few more minutes. And then you can ask and prepare your questions. This is your chance to ask a battery producer, to ask a plane producer, a composites technology center, and a taxi operator. Ask them. We are prepared for the most critical questions you may have. The last round, Eric, I would like to start on this one with you. The notion in the industry is, well, batteries are for single aisles, low seat number of planes. What is your stance on this? Do you share this public view?
I think it's an interesting question because I don't think it's necessarily untrue. Where we look at what the capability, what the actual capability or possibility is for the state of the art of batteries. But you can be pessimistic that way. I think we tend to be quite optimistic the other way. 100 years ago, if somebody had said, I don't know, that flying thing, I mean, that airplane only lasts 19 seconds in the air. Maybe we shouldn't do that. We wouldn't be sitting here, right? So things have to start in a way with the technology of the day and continue forward. And so I think we would look at it, maybe if I was going to break it down, I think we can kind of look at it in short, medium, and long term. For instance, so short term, we have these lithium-ion batteries kind of as the best choice right now. Maybe in the next 3 to 5 years, what we'll see is lots of work on high silicon anode, looking at things like pre-lithiation, really looking at making these things more producible so that we can actually get the very most out of that sort of range of technology. And that's really what CustomCells is working on right now. I think maybe the next one would be looking at maybe more hybrid sides, things like some advancements, maybe lithium sulfur, and maybe dominant design. So we're starting to share it, becomes more part of a known ecosystem as we go through. And maybe a little longer term, say 8 to 10 to 15 years out, these are big breakthrough technologies, or maybe high capacity systems, etc. In any way, I think you'd look at this like an evolution, like a move from innovation to innovation. It comes in waves. And I absolutely would not abandon where we are right now to say, oh, it's not worth it. I think this is really exciting. I think electrifying and changing this part and these hard parts of mobility is the key factor as we look at this energy transition.
I like the idea of the evolution you mentioned, but I would like to get a view now from CTC, from Marc, who started this with the overview of the different propulsion systems. Now, what we hear here is very encouraging, Marc, to be frank and fair to the producers. But you say we should not view aerospace industry as one-dimensional. But if we want to innovate and put evolution in the front, and now we know that aerospace R&D takes long time to get not only the R&D, but also the approvals homologated. Should the aerospace industry become a bit more riskier or think outside the box? What's your view on that?
I guess, first of all, we should be more sustainable. I guess it's clear. And sustainability means not only the ecological ones, all the dimensions we have to figure on, also the economic ones, the resilience, and of course also the social sustainability is really important because we need the acceptance of the customers in future. And I guess we are enthusiasts for aviation, and aviation in my mind collects people, collects cultures with each other. And especially in these complex times, that's really crucial. And maybe it will become in future more and more important. And we should count on this, and we should work for this sustainable aviation. When I come back to the complexity, we are not thinking more about just making a design for performance, design for function when it comes to the product. We also have a deep look into the industrial system behind, into the value chain. So designing for manufacturing, designing for assembly, designing for recycling, maybe for circular economy when it's possible. And this is designing for automation, for digitization. These are really important facts, but it becomes more and more complexer because we are not looking only for the product. We are looking also for the industrial system. And in my opinion, for this, we need more cross-sectional knowledge transfer. We need the exchange because when we look to the major trends, the mega trends, digital change, using artificial intelligence, come with up the climate change, then we have the same challenges in almost each mobility industry, in the total industry. And we need this kind of cross-sectional transfer. This is crucial for me. That's what CTC is providing. We are not only focusing on the aviation industry with our lightweight technologies and solution. We are looking in almost each mobility industry, and there are a lot of good options we can foster together.
I'm glad to hear that from you, Marc, because this is also one of our key values. It was the Composites Lounge that we said we want to enter into end user panels where we get the producers and even the operators together and get all the ideas involved. And we have this complexity. You are right. It's a complex system here. Now, I've mentioned to you my experience with individual flying with Norbert's Air-to-E company. And that was convenient because it was in the midst of the lockdown. And I thought at that time, wow, this individual flying thing in the lockdown, that has a huge, real future. And because planes were down, I did actually photo shoots at Stuttgart Airport where there was no flight at all at that day. So you all know this. I don't need to remember you. And now Markus, we are at the point where suddenly this year, July, August, we are back prior to the pre-COVID levels. Planes are full. Lufthansa has taken his, I think they have one A380 still left in Teruel. So all the others are already in operation. Also A350s are already in operation. So airline industry is in full swing. Where do you see yourself in the future with such an upswing on airliners? Where would you position yourself?
Well, at the beginning, I would say it's for sure the business aviation, which gives us the opportunity to step into the market, because with the new technology, we want really be competitive with existing ways of transport. We are looking for, we don't want to replace the railway, right? But we want to compete with kind of a first-class railway ticket in terms of pricing. So having the opportunity in the business aviation market and connecting, I don't know, management teams or whatever from A to B, or with the second use case, we have recently signed up with the ADAC so that we have patient transport, right? So that we have a different use case for this type of aircraft, where currently the patients are transported up to 600 kilometers just with a truck, right? So we give them more or a faster way to get to the hospital. So there are several ways to go, but at the end it will be we try to reshape regional air transportation, and this is the market we see ourselves.
Yeah, I'm glad to hear it. And of course, I'm interested in Norbert's view on this one. I'm sure Norbert will say there's a huge future. And please give us a reason why there's a huge future on individual flying.
Well, it's a new way of transport, I would say, because so far everybody is used to go with the airliner from Munich to Berlin or to any other cities, but only from big hub to big hub. Now it's a possibility that you have with your personal car, with a taxi, really to go from the point where you are to the point where you want to be. And this is the huge change of a new transportation mode, which is then in the air. So giving you the car in the flexibility of the car, but the possibilities that the direct connection through the air is giving you. So with airplanes like Vaeridion is developing, we have a new means of transportation, and that will give the aviation sector a whole new sector to develop into, which is then to fly individually, and that's, in our opinion, individual air mobility of the future.
Thank you so much, dear Norbert. As expected, very excited. Now, dear audience, thank you so much for being part of our panel. I hope you enjoyed it so far, and now it's your time. Is there anything in your mind that today needs to be discussed? A very urgent point. Please let it out now. This is your chance. So here we have one question.
Hello. How do you manage the fire risk in batteries, especially when you think about bird strikes or damaged cells?
Fire risk and damages.
The fire risk. Okay. There is one feature, and I will have Jan Diekmann, your colleague, in one of our future panels in Hamburg in a different context, and we will talk about thermal runaway. Do you want to talk about thermal runaway?
Well, I can give a quick answer. So basically, by regulation from EASA, nothing could escape the battery pack than warm gas. So we have to contain...
Sorry, then one?
Warm gas. Hot air.
Warm gas, okay.
Okay, so we have to contain all the fire and all the debris which could turn out from a battery thermal runaway within the pack.
So it's encapsulated, probably vacuum?
Well, there are different ways.
Different way. Okay. Thanks. It's a very good question and a great question, because everyone thinks of these Teslas on the road burning, and you have to let them burn down and all these things. And we don't want to have that in 10,000 meters of height, of course. Yeah. Anything else that comes to your mind that we need to consider?
So there was a question about lightning strikes. What do you do about against lightning strikes?
Okay, also Blitzeinschläge, lightning strike.
Well, every aircraft which is flying already has to be capable for lightning strikes. So we have to have lightning protection. And this will for sure be also applicable for the batteries installed.
Let me expand the question, if I may. So lightning strike for the plane, no problem. It will be abgeleitet in German, they say. But what about the battery management system? Is there any harm on that? Or is it a different?
I think what we have to say generally is that all of these requirements, airworthiness requirements that are already in place have to be met by these new aircraft, and they are. And so I think there's a lot of thought around this. Oh, it's a battery. Oh, it's a little different. But we're talking about massive amounts of very flammable fuel that's flying around the sky right now.
Good point.
And these systems are in place, and so it's a matter of meeting the same airworthiness requirements around a slightly different system.
Okay, great. One more question. Anything related to the battery in a plane or the plane construction, plane design, composites? No more? Okay, then I will conclude this round. Thank you so much, gentlemen. Norbert, the air taxi operator, will be flying soon with electric planes, flies today already. So if you have any individual flying needs, contact Norbert. He's on LinkedIn. By the way, I was humbled and honored to coach Norbert on LinkedIn. So he's crushing it on LinkedIn, if you want to meet. Then we have Eric, Senior Vice President of CustomCells, one of the most renowned battery producers here out of Germany. We have Vaeridion, a German manufacturer of electric planes. And then we have CTC here, Composites Technology Center out of Stade. Was it a startup or a corporate venture of Airbus in the past? Do you know?
I guess the explanation startup doesn't exist to this time, but
no, okay, yeah,
it's really similar to this, yes.
Okay. Thank you so much, gentlemen, for everything. I will be conducting some more interviews here. I will be conducting one interview with DLR. So if you have time, have a look at DLR Systemleichtbau. They have an MMX rover in Hall 4, booth 300. Then Teijin Carbon Europe is also in the board of BDLI. Thank you, BDLI, once again. I will interview Hinrich. So Composites Lounge will be providing you a lot of content on LinkedIn. Please subscribe to our channels, follow our channels. Yeah, and then we are ready to go. And I wish you all a nice show.
Well, thank you so much to you, Ilkay, and the whole panel for that very interesting 45 minutes. As we are now wrapping up another day of thoughtful, thought-sparking and inspiring discussions, we're already looking forward to welcoming you back again tomorrow morning at the ILA Stage Aviation Future Lab. See you tomorrow.